Exercise 2324 is asking us to use acetic acid, that's vinegar, or vinegar is acetic acid and water, to use acetic acid to make N-ethylacetamide. That's that molecule there. So our only source of carbons, we can't use any other source of carbons. Any carbons we add have to come from acetic acid. I think this one is fun to approach from a retrosynthetic perspective. So if we think about this product, how can we make that? What do we need to make that? Remember, what this retrosynthetic arrow means is I could make this if I have this other thing. Well, whenever you see an amide, or for that matter, any carboxylic acid derivative, you want to see the leaving group there, the group connected to the carbonyl, as a leaving group. And you can make this amide by taking that group by itself and then combining it with a more reactive carboxylic acid derivative. And the most reactive carboxylic acid derivative was an acid chloride. And so we can replace that with a Cl. So if we added these two together, ultimately the chlorine would act as a leaving group, and the nitrogen would act as a nucleophile and replace it, do a nucleophilic acyl substitution. Okay, so that's what we got just by looking at this and saying this is a carboxylic acid derivative. This piece that's connected to the carbonyl carbon can come on and off. We can replace that with other things. Now, we need to be able to make these from acetic acid. So if we sort of we need to be able to make those from acetic acid, or actually and we could definitely make the acid chloride from acetic acid using thionyl chloride. But how can we make the amine? Well, maybe we can use this acid chloride to make an amide, and then we can do a reduction. Because notice you have 2 carbons here, 2 carbons there, so we just have to get rid of the carbonyl, and then we would have that. So here we have a sort of plan for making this final amide from just acetic acid vinegar. So let's switch these arrows around now and fill in the recipes that we need. We can turn acetic acid into the acid chloride, acetyl chloride, by adding thionyl chloride, SoCl2. So then we just have acetyl chloride. Now, we also need ethylamine, but we can make that from acetyl chloride by first treating acetyl chloride with excess ammonia. That would turn it into ethanamide. And once you have ethanamide, we just need to get rid of that double bond to the oxygen. We need to reduce the number of bonds to an electronegative atom. We could do that in 2 steps using lithium aluminum hydride, followed by a water wash. Then we have these 2 reagents, and we would just need to react them together, and that would give us our product. So that overall, the synthesis for this would be first add thionyl chloride, SoCl2. Second, save some of this acid chloride, we're going to need that in a second, but use some of it to make an amide by adding excess ammonia. Then we can get rid of those 2 bonds to the oxygen by doing a reduction. That's 2 steps. First, add lithium aluminum hydride, and then a water wash. So at this point we will have both of these molecules, and we'll just need to add them together. And so, sort of in this fifth step, you might just mention the two molecules. And that's it. That would give you your product. So this was sort of thinking about amines, but maybe using the nucleophilic acyl substitution as a pathway.